So continuing with our video, as I have told you, this is the distance to find the displacement of a ship from one point to another along the same latitude in kilometer. This theta is the normal change in longitude. If for this case theta is equal to 20 degree of east minus 14 degree of east, which is equal to 6 on this case, on this sketch here. And alpha is that constant latitude. We were given, if we were given 50 degrees south of latitude at this point, which is this one, and again 50 degrees south of latitude with this one east, which is at this point, then we have a 50 degrees south, a constant degree, which is a constant latitude. Our ship says along the same latitude, and therefore alpha, this alpha here is this 50 degree. We would have to calculate other types of questions, how to find distance, and of course, in fact, we are left with how to find a distance in nautical miles in this case with the same latitude, and also how to calculate on how a ship can attain its destination when we consider the effect of wind blowing on the way of the ship. If a ship starts from one point to another, maybe this way, and you have a wind blowing from south to east, therefore this ship won't get to this destination, but rather it will somehow be displaced by this wind to this point, and therefore there will be an angle theta, which is caused by the effect of the wind. And there are vectors we write here, we draw, there are vectors we draw here. And therefore, there are some mathematics we have to do in order to make sure that a ship sailing from this point to this point reach exactly at the destination and not somewhere else. But we will describe that on other sessions. In order not to make this video too long, I have to stop at this particular point, and then I'll continue with other sections of the question. And now section B of this question. Section B. We are asked to sketch a square pyramid whose base is PQRS, vertex is at W, and center is at N. Then to answer the question that follows. First of all, we have to sketch this square pyramid. Square pyramid. This is a square pyramid. Let's assume it is square. Since it will take us a lot of time if we would have to use a measurement in order to make it perfect square. Therefore, let's assume this base is a square, and therefore we continue with the sides, and this will be a dotted line. This have to be a dotted line because it is on the other side of the pyramid. This one is a complete line, and this one is a complete line, and this one also a complete line. If we trace the center of this, then it have to be here. center of the pyramid, and therefore we have a line normal to the base of the pyramid up to its vertex. This is the W, the vertex. This is N, the center. And this is P, Q, R, S. And this is the sketch. And now we are going to the question. State the projection of RW on PQRS. The projection of RW. Projection of RW. RW is this one, and its projection on the plane PQRS is equal to this line here, is this one. And the projection of RW is equal to Rn. And how do we find Rn? This Rn right here. We have to complete this line, and therefore by using Pythagoras theorem we can say that this diagonal here, RQ, is equal to RS square plus the SQ square, then under root. And here it's clearly that RQ, since RQ is equal to 2 of Rn, our projection, therefore Rn is equal to a half of RQ, which is equal to 1 over 2 of RS squared plus SQ squared. And this is our projection of the plane RW, of the line RW on the plane PQRS. It's our projection. And then the second question, name the angle between WS and the plane PQRS. The angle WS and the plane PQRS. If we connect this line, we project this line to the center of this plane, we have an angle here, angle theta. And if we are attentive enough, we can see that the angles made by these lines with the plane PQRS, they are less than 90 degrees. There are angles of less than 90 degrees. Therefore, any angle less than 90 degrees and greater than 0 degree is, we call it an acute angle. Then our answer here, we say angle made by WS and the plane PQRS is an acute angle. And by definition, an acute angle is an angle theta which is greater than 0 and at the same time less than 90 degrees. From acute angle, we have a right angle also. Right angle, which is equal to an angle equal to 90 degrees. Right angle is an angle theta which is equal to 90 degrees. From right angle also we have an obtuse angle all these are names of the angle depending on the size of the angle. We have obtuse angle, which is an angle theta greater than 90 degrees and less than 180 degrees. Then from obtuse angle, we have also what we call a straight line. A straight line is an angle theta which is equal to 180 degrees. From straight line, you have also what we call a reflex angle. Reflex angle is an angle theta such that what is greater, angle theta which is greater than 180 degrees and less than 360 degrees. This is a reflex angle. And at the end, we have what we call a complete cycle with an angle theta is equal to 360 degrees. These are names. The name we were asked to name for that angle, this angle right here, the angle between WS and the plane PQRS, is called an acute angle. I've already wrote that. We have already answered that, but these are other names of angles depending on their size. And I have to stop here this video. I'll try to answer the rest of the question on another video in order not to make this video too long. Thank you very much.